Oh, well, hello everyone. Welcome to eCHO episode 169. Today, we're going to talk about Cilium IPAM. I hope you had a great week, and I'm happy to meet you today. I don't know why the little video didn't start today. Anyway, there's some news for today. There's been a Cilium release 3 days ago, release 117. So maybe we can start with this. It's going to be an episode dedicated to the new features in 117. But let me I'm going to share my screen here and just go quickly through the features in this new release. So Cilium 117 released 3 days ago. And what do we have? We have some new features in networking, including quality of service, thanks to Hemant. There is now a possibility to annotate pods actually, to add a quality of service indication for networking, similar to what you have already with pods in the way resources are attributed for workloads in Kubernetes. You can now do the same thing for networking. So this is really nice, and it works with the bandwidth manager in Cilium. The multi-cluster service API, you probably know that Cilium has supported multi-cluster with Cilium Cluster Mesh for a while, but that hasn't been a standard in Kubernetes. There hasn't been a standard for how this works. And now there's a new work group that has been working on this, on multi-cluster standard resources, in particular external services and what is it? Is external services and internal services, I think? No, export service and import service, sorry. Or service import, service export. I think that's how it is. And so now these resources will be used within Cilium to provide cluster mesh multi-service. Oh, hi, Joseph. Thanks for joining today. If you're joining us, whether you're on YouTube, on LinkedIn, or somewhere else, don't hesitate to drop a message in the chat and let us know where you're based. Then we have load balancing, supporting differentiation between TCP and UDP for protocols. So you can have different backends for the same service on TCP and UDP. This will be very useful for some people. Per service load balancer algorithms. So this is already possible in Cilium. You can already activate the maglev implementation, the maglev algorithm for services, and that's for north-south services in Cilium. And now in 117, it will be possible to actually choose if you want the random or the maglev algorithm per service. So you can have some services using the standard random algorithm and some other services using the maglev algorithm specifically. Deny list for service source ranges. So there's a new specification in services that's called load balancer source ranges. And this is a standard in Kubernetes. And this field allows you to specify which IP ranges are allowed to access the service. This can be super useful. And in 117, what was added is that you can now put an annotation on the service in Cilium to actually invert the logic. So instead of this range being allowed, it will actually be denied. Better control over IPAM. IPs can be allocated statically as well, maybe. IPs can be allocated statically using AWS tags, and multiple can support single IP ranges for both. We'll talk about this a little bit more today because we're going to talk about IPAM specifically. My understanding is that the IP allocation based on AWS tags is actually to assign elastic IPs to nodes specifically, whereas the multiple with single range IPs is actually for pod IPs. Dynamic MTU detection, so that if there is a change in the MTU, the Cilium agent will automatically adapt. Then what do we have? Some things on security, network policy performance. This is like essentially internal, but it works better, right? It's faster. Prioritize critical network policies also for the same reason. It's for performance. So the idea is that if you have a really big cluster, lots of services, lots of network policies, sometimes small changes might take some time to reflect in the network policies implementation in the data path. And with this, you'll be able to actually annotate the network policies to specify which network policies are priority to be enforced, so that they're actually considered before the others. Validated network policies, this is something we've been waiting for a long time, I think. And especially the several things in there. It's the fact that some combinations that actually do not work but were quite silent, or you had to look at the Cilium logs to figure it out, will be actually rejected. And there is a new field when you list the network policies with kubectl that actually tells you if the network policy is valid or not. So that will be super useful to detect which network policies are actually not enforced because they're not invalid. They're not valid. They're invalid. Right. Select CIDR groups by label for network policy selection. So CIDR groups is a resource type that allows you to declare, well, I can say it's a group of CIDRs with a name. And now you can actually address this CIDR group in network policies directly by label. So that's super useful if you want to reuse the same CIDR groups in multiple network policies. That can be very, very useful. Extend 2 services for in-cluster services. So this is a fun one, because I remember some years ago I had this question several times. People using 2 services in their network policies. And actually, 2 services until recently was not meant to be used for internal services, right? For internal services, so far with network policies, you're supposed to actually use 2 endpoints and target the endpoints, so the pods typically that you want to access. So you're supposed to know the labels of the pods, which might not match the service name or the service label. And so it was confusing for quite a few people. I think that 2 services actually didn't work internally. It was typically used if you wanted to write a network policy for a service outside the cluster, and still use typically an internal service. So you would create an internal service, make it headless, attach an endpoint manually, and then use 2 services to provide an abstraction to write the network policy. So now with 1.17, 2 services will actually be usable for internal services, and it means that it will actually figure out the Cilium endpoints that are attached to it, so the pods that are attached to it, and adjust the network policy accordingly. So this is super cool. FQDN filtering for host networks. So this makes it so that you can now write DNS policies for Cilium cluster-wide network policies, so the Cilium host firewall. So you can now have hosts that have egress policies allowing traffic to a DNS name outside of the cluster. HTTP policies on port ranges. So far you had to list the ports one by one. Now you can have a whole range, which can be useful, especially when you have like microservices that go from, I don't know, 8080 to 8090. You can now have a range. And then some news on service mesh. Gateway API 1.2.1 is now supported, including retries and mirror fractions, so you won't need Envoy coding for this anymore. Static gateway addressing. This is a specific feature in Gateway API that is similar to what we have with LB IPAM and Cilium plus the LB IPAM annotations, but now it's officially supported in Gateway API. Improved Envoy TLS handling. So this is a performance improvement, I think, to reflect TLS configuration, TLS secrets, and the way it is sent to Envoy uses a different mechanism as it did before. Now there's a new dynamic way of configuring Hubble metrics. And if you've configured Hubble metrics before, there's a lot of granularity in the way you can configure Hubble metrics, but you need to do so typically in the Helm chart. And if you want to modify, you need to modify the value passed to the Helm chart and then restart the pods. And so now it'll be possible to actually use a config map, and then if you modify the config map, then it will automatically reflect the values of the metric configuration without restarting. Trackable features using Prometheus. So this is a whole list of new metrics provided by the Cilium agent and Cilium operator that expose the features that are enabled. A lot of new metrics linked to lots of features, BGP network connections, network policy, pod management, and so on. And then some scaling improvements for connectivity checking, for rate limiting, double write identity modes for the KV store, better scale testing. So lots of very interesting features in there. For today, the plan will be to look a little bit more at Cilium IPAM. So when we talk about IPAM, to clarify, when we talk about IPAM in the context of Cilium, we can talk about lots of different things, actually. Because IPAM is a generic term of how do you manage IP addresses, right? And we have several things that need IP addresses in Kubernetes. The nodes need IP addresses, so there's typically IPAM for the nodes. The pods need IP addresses. This is usually when we talk about IPAM out of context, we mean IPAM for the pods. The services need IP addresses as well. So there's obviously the automatic IPAM that provides cluster IP addresses, and this is done automatically by Kubernetes. But if you make a load balancer type of service, you will typically also have a load balancer IP that will be added. And there's a component that can do this in Cilium that is called LB IPAM. And there's others as well. For example, if you use Cilium egress gateway, there's also an IPAM feature to attach an IP automatically to the egress gateway. So today we'll start by focusing on the Cilium IPAM, as in how we assign IP addresses to pods. I'll start a lab. This is a public lab that you can take actually to look at the different options for IPAM in Cilium. And see, this is from the documentation, and it kind of summarizes the different modes. So there's the Kubernetes host scope mode, and this mode, the Kubernetes cluster will attach CIDRs to each node using the node resources, and then Cilium will just make use of the CIDRs per node and cut them into pieces to assign the IP addresses to the pods. The default in Cilium is actually cluster scope, and cluster scope, it will be something similar. Cilium will essentially assign a CIDR to every node using the Cilium node resource and then use it for the pods. But as we'll see, there's actually limitations to this. And so the multi-pool mode, which is quite recent, actually addresses these limitations. And then there's some other modes that are specific to cloud providers. So let's get started with this. I'll zoom a little bit. There we go. So as usual, I'll be using a CAN cluster. And I have a CAN cluster that is not ready because I haven't installed Cilium, and there's 3 nodes, so a control plane and 2 nodes. And so how does it work, right? So Cilium will be the CNI once we install it. And so every time the kubelet needs to create a new pod, the kubelet will communicate with the kube API server, figure out that there's a new pod that needs to be created on that node because it's been assigned to the node where the kubelet is running. And it will call, it's actually not direct like this, it will call CRI, and CRI will create the pod and call Cilium CNI, so the CNI plugin, in order to get the network information to create the pod, right? And one of the tasks of the CNI plugin will be to provide an IP address for the pod, one or actually even multiple IP addresses potentially for the pod. So this is the IPAM scope. So what we're going to do here is we can actually look at the configuration, and at the moment on any of these nodes we don't have any configuration, so Cilium is not actually configured. And the nodes are not marked as ready because there's no CNI plugin. Maybe just a note here is that while the nodes are not ready, there are actually pods that are already running on the cluster. And the reason is that this pod, and if we do -O wide, we're going to see, the reason is that this pods actually use the host networking stack. You see here, they all have addresses in 172.18, and 172.18 is actually the IP address of the host of the node. And so when you use host networking, you don't need a CNI plugin. It already works because it uses the stack of the network stack of the host, which is already configured. So this pod is already working. They can already communicate using the networking stack of the node. The problem with this is that obviously we could start pretty much every pod in host networking. That would be a pretty bad idea because, well, first, if we're exposing services, then we're going to have port conflicts very quickly. If we have several pods that are exposing the same port on the same machine, we're going to have conflicts. And then from a security standpoint, it won't be really great either. Why doesn't CoreDNS use host network? Joseph is asking. Because it doesn't need to, essentially. It can work without using the host network. So at least by default, I don't know if this can be changed. Probably you can set it a different way, but at least by default, it requires a CNI. It works as a normal pod. And the service is exposed using a Kubernetes service, which we can see here. It's the kubedns service. And the kubedns service is a standard service that points to the so here endpoints kubedns -YAML. And so far, there's no endpoint for kubedns because the CoreDNS pods don't have IP addresses yet. So what we're going to do here is see, we don't have a CNI plugin. There's no binary here, what is called a type in CNI for Cilium. So we're going to actually install Cilium on here. Just going to pass on the quiz. Just practical to follow the instructions I have in the lab. It's already all scripted to explain. So I'll just show this first. So in the Kubernetes host scope IPAM, which we'll be using next, when Kubernetes sets up the cluster, that's all right, Joseph. It's not really a digression. It's interesting. So when Kubernetes sets up the cluster, it creates node resources, one for each node. And in these node resources, there is an IPAM section with the CIDR that is attributed to this node. This is typically what happens in kind, so the Kubernetes distribution I'm using here. And so in the Kubernetes host scope mode for Cilium, we're actually going to make use of that definition of the IPAM information that is in the node resource provided by the Kubernetes distribution, so kind in this case. You see we'll have a pod CIDR here in the spec, or pod CIDRs if there's multiple ones, and then the Cilium agent will be able to use that information to assign to the node. So if we look here, we see that actually, yeah, the kube controller manager on the control plane was actually started here. We can see allocate node CIDR equals true here, and the cluster CIDR here is the CIDR that is used for the whole cluster. So we have a /16, and essentially what Kubernetes will do, so the controller, is that whenever there's a new node, it will cut this into a /24 for each node. So we'll get 10.2441, 10.2442, 10.2443, and so on for the different nodes in the cluster. So we can actually look at this. We see here, this is for each of the nodes. I'm just looking for each of the nodes. I'm looking at the name and looking at the pod CIDR, right? So I could just do this, get node, can control plane, -O YAML, and we will see in the kind control plane here that we have spec pod CIDR 24400/24. So 00/24 for the control plane. Sorry. And then the first worker will get .1, and the second worker will get .2, and so on and so forth. So now if we install Cilium, so I don't know if you've noticed, but before I was saying cluster scope is actually the default in Cilium, and that's true. And so here we're specifying IPAM.mode, but just note that because we're using Cilium install doesn't actually use the default values. Cilium install actually tries to figure out the cluster we're installing on and finds the best values for the cluster. And so here it detected that the type of cluster is kind, and because it's kind, it would in any case use IPAM mode Kubernetes by default. So now we have this, and if we use that Cilium config view, and we can look at IPAM mode, and we see that it's Kubernetes. So what this means is that Cilium will use these CIDRs that are provided by kind to assign to the pods. So if we look at the pods now, a little wide, we can see that the pods have started. Where is this? Cilium. So Cilium is, again, Cilium is special. It's also uses networking for, I think, obvious reasons, is that it's actually managing the network. So it needs to access the host network. But core DNS that was pending before is now started, and it's received IP addresses. And you can see that both core DNS pods, for some reason, are running. No, not yet 117, Joseph. Sorry, I'm going to put the comment here. It's not updated for 117 because 117 was really 3 days ago, and we've had a lot of other things to do. But it will soon. It's planned. So core DNS is both core DNS pods are running on the kind control plane, and so they got an IP address in this range. We could restart them maybe just to see, right? Because why not? I'm just gonna kill this one. If I'm lucky enough, it will restart on another node. All right, let's see. Show wide. Remove this so we can see a bit better. Or do we have something here? Yeah, now it started on kind worker 2, which means now it's 10.244.269, right? So we get IP addresses that are specific to the nodes based on the providers, based on the CIDRs that are assigned to the node. We can see, by the way, the configuration, the CNI configuration on the nodes. This is on the first kind worker. And we can see the binary also that was deployed. So this is how this works. What can we see here? So IPAM. Yes. If we start new pods, let's run a netshoot pod here. And we're going to find on which node it's running. It's running on kind worker 2. We're going to get the Cilium pod for it. And then if we look at that Cilium pod, we can see it on kind worker 2, we have this range, 10.244.2.0, which is what we saw before. So it uses what was provided by Kubernetes. And we can see the number of IPs that are currently used by Cilium. So there's 4 IPs that are used by Cilium, and that includes the router and the health IP. So there's at least 2 IPs per node that are going to be used by default, router and health, plus 2 more, right? And the 2 more, there's this one, obviously. And yeah, we know that core DNS is also managed on worker 2 since I restarted it, right? So GKE, by the way, is an example of this. By default, GKE works with that mode. So when you start a GKE cluster, it will assign CIDRs to every node, and then by default, Cilium will use the CIDRs on every node to manage IPAM. So this is the first mode, and I started with this because it's probably the simplest, right? So in Kubernetes host scope mode, Cilium assigns deciders to each node. No, that's not true. Kubernetes assigns deciders to each node, and Cilium just uses what is already specified on each node in Kubernetes. Cilium reserves 2 IP addresses per node for host and health interfaces. This is true, with one little caveat since release 1.17, actually. So the new version has something slightly different, and it's this little thing here. In multiple, it can support single IP ranges. So it will be in multiple, actually, not in Kubernetes host scope as we saw. But there's an optimization here since 1.17, so that if you assign a single address using multiple, then it won't have host and health. In Kubernetes host scope mode, kind is limited to 256 nodes. This is true because we have by default a /16, and it gets cut into /24, so we can generate 256 CIDRs from the /16 if I count properly. And you need to use the Kubernetes host scope mode with Google Kubernetes Engine clusters. By default, yes, but you can actually use something else if you want to, right? So it's just the default. So the other mode, which is actually the default when you use the Helm chart instead of Cilium install, is the cluster scope IPAM mode. So very similar to what we just saw. The difference is that Cilium itself will assign the CIDRs per node, and it will do so from a base CIDR, just similar to what we had in Kubernetes, but Cilium does it. Did I test 256 nodes in kind? No, I did not do it. I did not test it, but I'm sure you'd be happy to do it, Joseph. You like to create a lot of clusters, so maybe a lot of nodes can be fun as well. So we're going to install Cilium again. Again, we have a new cluster. It was recreated from scratch, brand new cluster. We're going to install Cilium, and this time we're going to use the cluster pool IPAM mode, which, as I said, is the default usually. Let's wait until Cilium is ready. So it's starting. Probably another article. Yeah. I already don't find the time to read all your articles. All right, so this is Cilium starting. Let's maybe already have a look at the configuration here. So what we can see here is that IPAM uses cluster pool, and this is the default CIDR that was assigned. You can already see it's actually larger than what kind has by default. So by default, we use 10.0/8 with a mass size of 24 for the nodes. So this means that every time we create a node, we're going to get a /24 based on this. So we can actually have many more nodes than we did with kind by default. Just to note here is that the nodes still exist, right? And they're still configured by kind. And when I installed kind, I actually did not, I'm pretty sure it must be possible in kind to remove that feature that was assigning the pod CIDRs, all right? Because it's an option passed to the controller. I did not disable this, so kind is still assigning the pod CIDRs. It's just that we configured Cilium in such a way that it will ignore it, right? So these pod CIDRs are here in the node definition, but they're totally ignored by the CNI plugin. Instead, what we're going to use is Cilium node definitions, right? So you see we have one Cilium node definition per node. And in the Cilium node definition, there is actually an IPAM configuration. And you can see here the IPAM configuration. Where is this again? We have the health, we have the IPAM here, pod CIDRs, and it's by default, this got the first range, which is 10.0.0/24. And then the next one will get, oh yeah, I listed all of them. So in kind worker, we'll get .1, and kind worker 2 will get .2, and so on and so forth. It might not happen in this order, by the way, right? It could be totally random, because the nodes might not get assigned to Cilium in order. So again, we can list the nodes and the CIDRs that were assigned. Again, if we start a new pod, we're going to see that they receive an IP address. And that this IP address, again, we're looking to Cilium, and we can see that there's 3 IPs that were aligned out of 254. So that's, again, health, router, and the pod that was started on it, which is the NetShoot pod, right? So very similar to what we had before. The difference is we can actually specify whichever CIDR we want for the cluster. But there's some limitations. And one of the limitations is that if we exhaust the number of IPs we have in our CIDR, then we cannot really add more. Well, actually, we can add more, but only for new nodes. But we can not add to a node that already exists, right? So one node, one pod CIDR. So here was the new what's that called? Multi-scope? No, it's not multi-scope. It's called, what's the name again? I don't remember. With the new mode, we'll be able to assign multiple CIDRs to one node. So we're going to play with this. No, first, sorry, I'm a bit confused. The first thing we look at here is actually multiple CIDRs with the cluster scope mode. So we're still using cluster scope, but we're going to actually have multiple CIDRs. And voluntarily, I actually made small CIDRs, so /28, because this way we will exhaust them very quickly. And we're going to create /29 per node, so that we will exhaust pretty quickly as well. So we can install Cilium with these values, right? So again, Cilium install is essentially nowadays it's a wrapper around Helm, right? It just detects the cluster type, fills in default values, and then you can override the values either using -- value or using -- set, just as in Helm. So if we look at the configuration, we can see that we actually have 2 CIDRs that are assigned, and we want a /29 per node. And so for now, see what happened. The first node got the 42.0. It's actually worker 2 that started first. So it got 10.042/0.0/29, right? This is the first range from this IP CIDR. Then the control plane got -8/29, which is the second range. And with that, we've actually depleted this whole CIDR. So we need a new CIDR. And because we specify multiple CIDRs, then we can assign a second range to the third node, which happens to be kind worker in this case, right? So this means that Cilium is not limited. If one range is depleted, it can use another one. And if we were to deplete this one, we could still upgrade Cilium with another range, and that would work fine. So if we look now, we can see that Cilium is using 2 out of 6 here, because it's a /29. So we have 6 IPs, and 2 are used again for health and router. And if we start a new pod, again, we can see, I'm starting lots of pods actually. It's a deployment with multiple pods, and they're starting on multiple nodes. And you see one problem is that at some point, we've actually used all the IPs that we could have. And there's actually no way to solve this, right? So if I take the first pod here running on kind worker 2, and I look at the pod, you see the pod cannot be created because the CNI plugin, so Cilium is answering unable to allocate IP via a local Cilium agent. The range is full. And indeed, if we look at let's get the Cilium pod on which this pod is running, and then we look here, we have 6 out of 6 allocated. and we're stuck. There's nothing we can do. So we can actually allocate multiple CIDRs to the cluster, and they will be spread between the different nodes on the cluster, but then we're stuck if one specific node doesn't have IPs anymore. Let's say, we're using 256 IPs per node. Once we have 254, what did I say? 256, right? Once we have 254 IP addresses used for pods, we cannot create more, which could happen with really small microservices, right? So then we're going to look at the multiple option, and the multiple option will actually allow us to keep adding CIDRs to the same node to replete the number of IPs available per node. So what this means is that in the Cilium node CRD, we can have multiple pools, and these multiple pools will have names, and we can attribute IPs to pods from these multiple pools, right? So this will make it more flexible. So again, here I'm starting with a cluster that is not ready. Nothing is installed. Cilium is not installed, right? Again, starting from 0. And what we're going to do here is multi-pool actually only works with direct routing, right? It's not compatible with tunnel, and we've been using tunnel so far because this is the default. Usually when we do direct routing, we might want to use like a BGP infrastructure, but we're not going to do this here. We're going to keep it simple. So we'll just use the L2 auto routes functionality. So we'll have direct routing, but the nodes will exchange their routes automatically without using BGP. So this is done by configuring Cilium with routing mode native, so that's we don't tunnel with VXLAN or Geneve. We're going to use auto-direct node routes true. This will use layer 2 for the routing, the route exchanges between the nodes. And we'll use a native routing CIDR of 10/8. So everything that is 10/8 will be internal to the cluster. And then we will configure the IPAM. Let's have a look at this. We will configure the IPAM as well. So mode will be multipool. So again, this is fine because I'm using routing mode native. And we will create one pool by default. It's called default, actually. It's an IPv4 pool, and it's a 1010/16 with a mask size of 27, which means, again, we won't have a lot of IPs available per node, right? Because here we don't really care about the number of nodes. We care mainly about what happens when we deplete the number of IPs available on a single node. Yeah, and because we're using direct routing and we're using KPR, are we using KPR? Yes, we're using KPR. So we're replacing QProxy with Cilium. Again, here I actually have QProxy running. No, I don't. I don't have QProxy running. So I actually need QProxy. Great. So I actually remove QProxy from kind here. And because we're replacing QProxy, we also need to specify the service host and the service port so that Cilium knows where to find the Kubernetes API in the cluster. So the most simple thing to do in the context of kind is to use kind control plane, which is the name of the control plane node, and 6443 to access the API. Don't do this in production. This is not good. It works really well for labs. So now we're installing Cilium, and if we look at the configuration, we have IPAM configured to multipool. Maybe we can look at the routing. We have routing mode native, which is what we wanted. Native routing CIDR is 10/8. And if we look at IPAM, this is all we have actually for now. So we have actually created a default IP pool. It's in the IPAM section of the values, right? And actually what this did is that it created Cilium pod IP pool that is called default, and we can actually look at it using YAML, the YAML format. So you see it's a resource called Cilium pod IP pool. The name is default, and the specification is an IPv4 CIDR, which is specified to be 10.10.0.0/16 with a mask size of 27. So each node will receive a /27. So yeah, the logical thing to do now would be to actually look at the Cilium nodes. If we look at the Cilium nodes like can control plane -o YAML, we see that we have 10.10.0.64/27. Maybe actually I have, let me see, where's this comment that I used before? Something like this. Yeah. Nope. Oh, because it's not called pod CIDR. No, it's different because it uses pools. It's an IPAM pools, right? So I can't use the same command. So in IPAM pools, I have the pools that are requested and the pools that are allocated, right? And so here it says for pool default, I have this CIDR, and needed IP addresses is 8. Now I can create a second pool if I want to. And so here we go. I create a second pool, and this second pool is called Mars, Cilium pod IP pool. And now I have default and Mars. And Mars is also an IPv4 pool, and it provides 1020/16 with a mask size of 27. Now, if I look at the control plane, I'm still only using default. It doesn't use the Mars pool yet because I don't need it at this point. So now I'm going to start new pods. So this is an Nginx deployment with 2 replicas. Let's start this. So one thing we can note in this is control get deploy Nginx Mars. What we have here is we can actually specify in the annotation for the pod, we can specify which IP pool to use. So we can either let the nodes figure it out and choose the right one, or take from an IP pod if necessary, if you need more pods, more IP, sorry. Or you can specify exactly which IP pool to use. So here, if I look at the pods, I can actually see that the IPs were taken from the Mars IP pool, which means I can decide, I can have multiple pools, and I can decide for specific applications to choose a specific pool of IPs. This is actually, I remember talking with some ex-colleagues about this. I think it was at KubeCon in Paris, where they use something similar to avoid using egress gateway typically, by assigning specific pools to an application and doing native routing, and then they knew that this specific CIDR was assigned to a specific application. And since they use native routing with BGP, then they saw these IPs coming directly to applications outside of Kubernetes, so they could figure out the identity. So yeah, everything is deployed, and we can see that we got IPs in 1020. If we check the node, then we see that we have IPs that were allocated both in 1010 and in 1020. And we can see the amount of IP addresses actually that are needed in both. Now, if we scale up, let's scale up to 70 replicas, and let's wait. So now we have lots of pods. Yes, lots of pods. And obviously some of them are not starting because we don't have enough IP addresses for 70 pods in this cluster. So we've used all the 1020 IP addresses. well, we haven't used all the 1020. We've used all the /27 we've assigned to nodes, right? So now if we look at the Cilium node for CAN worker, we can see here that we need 35 IP addresses, and we can't provide that. Right. So with multiple CIDRs that were assigned, actually it works now. Yeah, it works now. What happened is, I just noticed this, is that for the different nodes, so for CAN worker and CAN worker 2, what happened is that Cilium actually automatically assigned new CIDRs from the Mars pool. So now CAN worker has 2 CIDRs from the Mars pool, and CAN worker 2 has 2 CIDRs from the Mars pool. And because we've told Cilium to assign by /27, it assigned multiple /27. Obviously, the limitation to this is that every time you assign a new /27, you have to have new health and router IPs, if I'm not mistaken. Now, if we scale down, we go back to 1 replica and wait until everything is scaled. Yeah, this is pretty fast. Now, we should lose these CIDRs at some point, if I'm not mistaken. There you see the needed is going down. And now we've lost this CIDRs, so they can be re-attributed to other nodes if necessary. So this makes it much more flexible than the default cluster scope mode. And finally, we can actually look. So let's do the little quiz here. Cluster scope is the default mode. This is true. And again, when you do Cilium install, it might select another mode just because it detects the type of cluster. In cluster scope mode, Cilium assigns CIDRs to Cilium node resources. This is true. Cluster scope allows to allocate multiple CIDRs per cluster. This is true, but not per node. Cluster scope only allows 1 CIDR per node. If you want multiple CIDRs per node, you need the multi-pool allocation, which again is limited to native routing. And then one very specific type of IPAM or mode of IPAM is what we call CRD-backed. And in CRD-backed, the idea is that instead of assigning a CIDR per node, we can assign IP addresses individually. And this is typically what is used in the ENI mode for EKS. When you use EKS with the ENI mode, you have the Cilium operator, which will communicate with the AWS API, and it will request IPs from the VPC IPAM and assign those IPs to the node, sorry. So the operator will assign the IPs to the nodes individually, and it will configure the VPC router to say, hey, this IP has been assigned to this node, so you need to route the traffic through this node to access it. This is how it works under the hood. So in order for this to work, you actually have to have a controller that will do this, right? So you will install Cilium in CRD-backed mode, but then it's up to you to have a controller that will actually modify the Cilium node resources to assign the IPs. So again, the ENI mode does this automatically, but you can actually have your own script if you want. So what we're going to do here is we're going to create a little script. And this little script here, I hide this thing. There, I don't want this. Never mind. I have a little script called allocate IPs. It's not extremely elegant, right? It's just for a demo. And the idea is that I will pass the name of the node where I want to allocate IPs and the number of IPs that I want to allocate. By default, it will be 10. So when I have the name of the node, I can look at the node CIDR. And what I will do here is I will pretty much allocate from the node CIDR provided by Kubernetes, right? I'm cheating a little bit, but this is so that I don't have to code and enter logic for this, right? Again, you could do whatever you want if you want to have your own logic. So the idea here is I will take the node CIDR, I will choose some random IPs from it, and assign them to the Cilium node by patching the Cilium node. So if I look here, first I will need to, well, let's see. I will need to install Cilium. There we go. So we'll use native routing mode with auto-direct node routes like before. Everything that is in 10/8 will be internal to the cluster, and we're going to masquerade IPv4. And the IPAM mode is CRD. So once I install Cilium with this, it's not going to do anything, right? So we have our pods. Cilium is installed, but the pods like Cilium Envoy, for example, or Core DNS are still pending because there's no way to assign IPs because we haven't provided the IPs to the nodes. And by the way, Cilium status -- wait will hang because typically Cilium Envoy will not start. So it's okay. Let's unblock it ourselves. So I'm going to use the allocate IPs script that I showed before, and I will start by calling allocate IPs can control plane, and I will allocate 4 IP addresses. So like I said, it will choose random IP. Okay, I need Cilium nodes to be ready still, right? And it's not ready yet. There, now it is. Right, I needed the agents to be started at least so they can create the Cilium node for each node. So now it's actually gotten the CIDR for the node. Again, this is because it's more practical, but it could be anything. And it's assigning IP addresses randomly to the node. And so what happens now is that if I look at the can control plane node, you see now what I have in IPAM is I have individual IPs that were added. And these IPs can now be used. So now I can actually have, you see here, everything has started pretty much. This one is creating the bottom one, but let's see, what do we have here? Where is Core DNS, for example? Core DNS is started on the can control plane, and so it received one of the IPs I've attributed. And you see that these IPs are totally not correlated. There's just IPs I have provided to the node. Now I can do the same on the kind worker and kind worker 2. And so what happens now, if I look at control get node kind worker -o YAML, we will see here in the IPAM section. No, it's not node. Sorry, it's Cilium node. You see that in the pool, I have these IP addresses, and 2 of them are used, 124 for health, 1220 for router. And so I have 2 more IP addresses that are available and not used. So now if I look at the Cilium status, everything is actually started because we provided enough IP addresses. And again, I have this, I'm keeping an eye on the time. I have this core DNS that is actually started on, let's do correct core DNS. They're both started on the control plane, so I could kill this one of them, see if it will start on another node. And see, it started on kind worker and it got an IP address that was assigned to kind worker. I know because I've chosen them from point 1, but again, it could have been anything, right? We could totally have random IP addresses in 10/8 assigned to any pod in any node. It doesn't matter. Yeah, so that's it. If we start more pods, let's do deployment with 30 pods. and wait for them to be ready, and it doesn't get ready. Why doesn't it get ready? It doesn't get ready because we haven't assigned enough IP addresses, right? So what we can do is just allocate more IP addresses, right? So allocate IPs. Let's do kind worker, and we'll allocate 20. So we're getting random IP addresses that were not assigned yet. I'm cheating a little bit. If you saw in my script, I have some files here where I record the IPs I have already allocated. I could get them from Kubernetes actually. You could probably improve this. And so now I have more pods that are started. I'll do the same on kind worker 2. And that should unlock. Oops. No, that's a lot. I've assigned a lot of them. And you see that my pods are starting because they're getting IP addresses. And again, the IP addresses are pretty much all over the place because I'm taking random IP addresses in the range. So yeah, again, AWS CNI and Azure IPAM typically use a form of that CRD-backed logic, except the logic is coded in the Cilium operator, so you don't see it. But potentially you could adapt this to your own infrastructure. If you have an IPAM provider, you're using direct routing, you have an IPAM provider, you want IPs taken from your own network, you could totally create your own controller for this. Yeah, never mind. I put too many. Anyway, I'm not going to do the exam anyway. All right, but that gives you an idea. We don't have time for this, but like I said, IPAM also in Cilium covers other things like how to assign IP addresses to services. That's what we call LB IPAM. If I had the time, I would go through this. There's like 2 labs called LB IPAM L2 announcements and LB IPAM BGP, which cover this. And the logic is similar, is that you have CRDs in Cilium where you can have, it's called LB IP pools, load balancer IP pools, and you can put CIDRs in there and then define the conditions, the selectors on services, which will assign these IPs to the services. And so Cilium will assign the IP address to the service when you have a service of type load balancer. And now, obviously, that won't automatically make this IP address routable from the outside of your cluster, which is why there's several options for this. Either you choose an IP that is already routable and you configure your network for this, or you can announce the IPs using BGP or using L2. So that's it for this little IPAM session. I hope this was useful. And again, this lab is actually available online. You can find it on isovalent.com/labs. You can also find it, I think, on cilium.io. There is the Cilium IPAM lab here. And if you finish it, you actually get a badge. And yeah, you can take more time to actually go through the different concepts and understand how they work. So I hope this was fun, and I wish you a good evening, a great weekend, and I hope to see you another time. Bye.